AOPS number theory 11.27. Evaluate the infinite geometric series, this, as a fraction and find the first 6 digits in its decimal expansion. So the first term, since the first term is 1 over 100, and the common ratio that they have in all of these fractions is 7 over 100, this is equal to 1 over 100 divided by 1 minus 7 over 100, which is equal to 1 over 100 divided by 93 over 100, which is equal to 1 over 93. And if you do long division and find the first 6 digits, is 0.010752. AOPS number theory 11.28. Let P be a prime number other than 2 or 5. What is the maximum possible number of digits in the repeating block of digits in 1 divided by P? So there are at most P minus 1 remainders after each step in long division. So for example, if we use 7, 1 divided by 7 is 0.142857, and over here the repeating cycle is 7 minus 1, P minus 1, which is equal to 6 digits. And this is because if you do all of this, and when it gets to P minus 1 digits, it goes back to 1. So when it goes back to 1, it's basically like this all over again at the bottom. So this is the cycle. So once the remainder repeats itself, the whole cycle repeats. So the cycle is at most P minus 1 digits. AOPS number theory 11.29. A. How many digits are in the decimal expansion of 10 to the power of 30? B in 2 to the power of 30, and C in 5 to the power of 30. So in 10 to the power of 30, there's 30 terminal zeros with a 1 at the beginning, so 30 plus 1 is 31 digits. And B, 2 to the power of 30 is equal to 10 to the power of 3 plus 24 in brackets to the power of 3. You can test that with the formula. So if you take this apart, that's the formula. If you take it apart, then it would be 10 to the power of 9 times all this. And then since 10 to the power of 9 is less than 2 to the power of 30, which is less than 10 to the power of 10, that means there are 10 digits. C. How many digits are in the decimal expansion of 5 to the power of 30? So 10 to the power of 9 over here is less than 2 to the power of 30, which is less than 10 to the power of 10. So that if we change it a bit, it will turn into 10 to the power of 30 divided by 10 to the power of 9 is greater than 10 to the power of 30 divided by 2 to the power of 30, which is also greater than 10 to the power of 20 over 10 to the power of 10. And so 10 to the power of 21 is greater than 5 to the power of 30, which is greater than 10 to the power of 20. And so 5 to the power of 30 is the same. It has the same number of digits as 10 to the power of 20. So there's 21.